Okay, in this lecture we're going to discuss how we evaluate the radical, the nth root of a to the n. Now I want you to be absolutely clear about this, that we just can't simply write, for example, for the square of x, we can't do this, okay, just straight out like this. Because if you look at this for x is equal to, say, -3, then what we'd have is the square root of x squared would in fact be the square root of -3 squared, okay, which of course is the square root of 25, and that's the square root of 9, and so that's clearly notice this is the positive square root, the principal square root, and so we'd end up with 3, and these two here are not equal. So when we have a square, we have a bit of a problem going on. Now, to take care of that, what we do is we use the absolute value. So in other words, if I now do this by saying, well, the square root of x squared is going to be equal to, say, the absolute value of x, okay? So if that's the case, then of course the square root of -3 squared would in fact be the absolute value of -3, okay, which of course is 3, and that goes along with what we have here, okay. Alright, so when we have a square root, there's a certain issue that occurs, and so what we do to alleviate that is use the absolute value. And so if n is an even, positive integer, right, then what we do is we say the nth root of a to the n is simply the absolute value of a. If n is an odd positive integer, then it doesn't matter, because remember, if it's odd, we can get a positive or negative answer. So the nth root of a to the n is simply a. Okay. All right. So let's look at some examples of this. All right. Let's suppose we want to simplify each of the following. All right. Alright, part A. Let's suppose that I have the square root of x to the 6. Alright, so this will of course be the absolute value of x cubed. Okay. Alright, because we've got an even integer and we've got a square root. Okay. So notice that we have that absolute value because the cube root of a number could be positive or negative, so we need to take care of that. So let's look at part B. Let's suppose I have the 7th root of p to the 7. Well, this is simply going to be p because we have 7 here and we have an odd root, but we have n, alright, which is odd. Okay, so coming up here, notice we have an odd, then 7th root of a to the 7 will be a. In this case, we got p. Part C. Right, what if we have the square root of 64 x to the 8 y to the 10. Okay, so in this case here, of course, the square root of 64 is fairly easy, so that's 8. Now, of course, we have a even and an even, so this will be the absolute value of x to the 4, okay, and this will be the absolute value of y to the 5. Of course, x to the 4 can only be positive, and so that will be my result. Okay, what if I do this one? Let's suppose I want the fourth root of -5 to the 4. Now n is even here, okay, and so this is going to be the absolute value, of course, of -5, which of course is 5. Okay. All right, what about, let's do part E here. What if we have the fifth root of r to the 10? Okay, so in this case here, we have an odd one, okay? And so in this case here, of course, we will have, this will be the fifth root of r squared to the 5, right, which of course will be simply the absolute value, well, it's odd, so it doesn't matter, it's just r squared, okay? All right, let's try the next one. Let's suppose that I have the square root of 2y subtract 3 squared. Now remember, this is a square, so n is even, so we've got to go up here again, n is even, so this is going to be the absolute value of 2y take 3. Right, and g, let's suppose that I want to find the square root of x squared minus 8x plus 16. Well, of course, this will be the square root of x take 4 squared, and of course this is squared, so it's going to be the absolute value of x take 4. Okay, so that's how we do that. Alright, so we've got some basic rules for radicals here. Right, and these are the rules. Okay, so here we've got A and B are positive, or rather are reals, real numbers. And let's suppose that M and N, right, are positive integers. Okay, so what we have here is rule number 1 is the product rule. If I have the nth root of A times by the nth root of B, this is simply equal to the nth root of the square root of AB. Alright, number 2, right, we have what's called the quotient rule, which says that the nth root of A over B is simply equal to the nth root of A over the nth root of B. Of course, B can't be equal to 0 here. We'll be trying to divide by 0. Right, number 3. Okay, we have a power of the power. Let's suppose I have the mth root of the nth root of A. Then this is simply the mnth root of A. So you do the product. So it comes from the index laws, really, or the exponent rules that we've seen before. Okay, so let's do some examples. So let's simplify. Alright, part A. Alright, let's suppose we want to do the square root of 5 by the square root of 45. Right, so this of course will be the square root of 5 times 45, which will be the square root of, what's 225, which is equal to 15, of course. Right, part B. Suppose I have the the seventh root, say. So the seventh root of P times the seventh root, well, let's make it P cubed, and the seventh root of P to the 4. So this will be the 7th root of p to the 3 by p to the 4. And of course now we use the exponent rules. This is the 7th root of p to the 7, which is p. Right, let's do part C. Suppose we have the square root of 11 over 169. This will be the square root of 11 over the square root of 169, and the square root of 169 will be 13. Okay, let's do part D. Let's suppose we have the 4th root of a over b to the 8. So this will be the 4th root of a over the 4th root of b to the 4 squared, which of course is the 4th root of a over, let's have a look here, so this will be b squared, which is positive, so it's going to be b squared squared, which is the 4th. Okay. Alright, and part E, let's suppose that we have the 3rd root of the 4th root of 7. This would be 3 fours are 12, the 12th root of 7. Okay. Alright, so that's a 7. Alright, now, what if we now have just simply the square root of the 4th root of 8? Then this is a square root, so this would in fact be 2 times 4 is 8, so this would be the 8th root of 8. Okay, and that's what we would get. Okay, so that's how we do simplifying radicals based on these rules. Remember this situation when it's even, and it doesn't matter when it's odd. Okay, make sure you remember the rules. Right, the product rule, the quotient rule, and of course the nth root of the nth root rule. Okay, called the power rule.